Well, thank you everybody for staying for the eDNA subcommittee series of talks. First, I just want to introduce the overall session. The goal today is to provide a couple of different pieces of information. First, an update in the eDNA subcommittee. And I guess the big picture goal of that subcommittee is really to create the information and education that allows for a informed discussion, and more importantly, I think, collegiality between the NGOs, the managers, the researchers in this room to really have some good discussions that hopefully end up in a product that we can all use and believe in. And then after that, we have a series of talks by Chris Merkis. Where did Chris go? There he is. Chris over there. He's coming out from the USGS in La Crosse, Wisconsin. Chris's research group has been doing a lot of work on zebra and quagga mussels, but I think in this case, more applicably, also on Asian carp. They're pretty much the premier research group in the Great Lakes area, really trying to feed feed molecular tools to other managers, specifically the U.S. Fish and Wildlife Service, and really try to point out and identify limitations of molecular tools, including eDNA, and also best uses. So they're doing a great job out there, and Chris is going to hopefully share some of that information, and more importantly, really try to broaden the discussion for how else molecular tools like eDNA are being applied to invasive species issues. And then we also have a talk by the U.S. Forest Service National Genomics Group here in Missoula. That group has been one of the, I guess, kind of the founding members of the eDNA research collective. They've been doing amazing eDNA work since about 2010 here in Missoula. And again, they're going to hopefully try to point out how what they're doing is applicable to invasive species, but also try to broaden the understanding of how this tool can be used for other issues, including T&E species, amphibians, and many other instances. And then we also have a talk by Gordon Lucard at Flathead Lake Biological Station, who's been helping the state do a lot of the environmental DNA monitoring for zebra quagga mussels. And he'll be talking a bit about some of the new approaches they're using to try to hone or increase the sensitivity of the technique. And I think as all of us know, eDNA has become a fairly heated topic the last few years for many reasons, especially as it relates to zebra quagga mussels and early detection. So I'll talk a bit about that as far as the eDNA subcommittee goes, and I'll try real quickly to just try to overall simplify what the current problem is. And again, this is a simplification. There's a lot of nuance and different directions we can go here, but in its simplest form, there's a general need for a better tool out there. We know that invasive species, when they're rare, any species when they're rare, are very hard to find. eDNA has proven itself to be a very sensitive tool for inferring species presence. And I italicize the word inferring because we're out there looking for the species DNA. We're not out there looking for the species. So it provides indirect inference that something is potentially present. Again, all we get is a DNA signal. And so we know this is a very sensitive tool that also has a much lower rate of false negatives than many other tools. But there's a trade-off in that it has a very low false negative rate. It has, arguably, maybe a little higher false positive rate or a misleading positive rate. Again, we're out there looking for just the DNA of that target species or maybe multiple target species. But presence of the DNA is not the same as presence of the species. And so when we have an eDNA positive, it could be from many different things. It could be because we have the species present. It could be as some of the research that Chris did years ago for Asian carp. It could be because of a bird that ate an Asian carp, then flew a couple hundred miles, or how long? Depending on the bird, you know, a couple hundred miles, and then pooped in the river and introduced DNA, so this exogenous material. It could be a dead individual, or it could just be DNA residue. Okay, so there's many different ways to get DNA into the water, one of which is species presence. And so it produces a lot of uncertainty in what an eDNA positive means. Managers and other groups often feel that there's too much uncertainty. They don't know how to use this information to make very consequential decisions, decisions that often have huge socio-political costs and huge economic costs. Researchers and others that support the tool proclaim eDNA works, and we should be thinking about the precautionary principle, and that the costs of false negatives from a traditional tool are greater than the costs of false eDNA positives. And so there's kind of this back and forth going on over the last couple of years, and one that's really been taking place with many people in this room. So it's a difficult problem, but I would argue it's not an intractable problem. And so the eDNA subcommittee is really, that's kind of the focus of the eDNA subcommittee, is how do we make forward progress? How do we figure out if we should use this tool, when we should use it, how we should use it, and what kind of decisions we can make off of it. So we have three primary goals for the subcommittee. One, again, is just to really produce an atmosphere of informed discussion, to make sure that everyone is indeed aware of what eDNA truly is. And the way we've done that to date is through a webinar that really provided kind of the molecular biology 101 on what is eDNA. And then hopefully this winter, we'll be having a State of the Science webinar on the specific applications of eDNA as it relates to zebra quagga mussels. Second is to hopefully draft a white paper that really tries to lay out and explain what we learned through these discussions, through this back and forth, and also through a review of the state of the science. So we hope to have a white paper to provide to this group, hopefully this time next year, if not earlier, that really lays out appropriate uses and limitations and how managers can think about using eDNA and other tools that provide information with some element of uncertainty for making decisions. And then finally, we hope to come up with some SOPs for field collection and lab analysis, since there are a lot of different groups doing eDNA collection and a lot of different groups doing it in different ways. And I think Gordon will try to highlight some of the different ways out there, especially as it relates to field collection. All right. So again, progress. We did our Bio 101 seminar this past April, and then hopefully we'll have a State of the Science webinar coming up this winter with a focus on dry synods. With regards to the white paper, myself and a few co-authors have provided a draft to the eDNA subcommittee that really tries to flesh out this idea of is eDNA ready for invasive species management? And it has 4 different parts to it. We briefly review if eDNA is a mature science. We try to explore challenges of integrating eDNA into invasive species management. We figured out how other fields that have done, that use molecular tools like DNA forensics, both in humans and in wildlife, how they've transitioned from research to application. And then we suggest some next steps for invasive species management. One of those next steps is this decision tree or flow chart that you guys were provided with. That's going to hopefully be the focus of our discussion. And we've circulated this draft to the subcommittee, and the goal here is to figure out, based on this draft paper, what are we missing? What do we need to further flesh out to make this a useful white paper for this group here in this room? Right. Other progress on SOPs. We've put out, my research group and Chris's as well, worked with a few others, have put out some SOPs suggesting, what are some approaches we can use to gain more confidence in the lab of what a positive DNA sample may mean. So we put forth some multi-phase criteria for actually saying a sample is positive for DNA. This has been, we have 2 publications out on this now, this past year. I can go into the details on that later, but the goal here is, again, we're using multiple criteria instead of just one criteria for determining whether or not a sample, once it gets to the lab, is positive or negative for DNA. Second, we're also looking at how good of a job our lab's doing. We just finished up a round-robin study where we sent samples out to 4 labs. About 3,000 samples were sent out, and we looked at repeatability and reproducibility of those results. So repeatability is, given the same test material in a lab, how often do you get the same result? And reproducibility is, given the same test material across different labs, how often do you get the same result? Trying to make some progress on this idea of, if I send my sample to this lab and I get a negative and I send my sample to that lab and I get a positive, eDNA doesn't work. Everyone's giving me a different answer. So we're trying to review this idea of what are lab protocols that result in high repeatability, high reproducibility. Our results to date, the reproducibility scores were 90% approximately. I think one thing that's really important to point out is we had a 0.7% false positive error rate. Meaning that if we got a sample in a water, for example, that we knew had zebra mussels, maybe we detected a quagga mussel, even though it didn't have a quagga in it. So very low rate, and also a very low false negative rate. So if we got a water sample from a water that we knew had zebra mussels, and we got a negative, out of about 3,000 samples, 0.7% and less than 9%. So very low error rates and very high repeatability and reproducibility. So we hope to get these protocols out to the WR subcommittee to review, and we're going to begin to make progress as well on field sampling protocols, handful of different ways to explore how to sample. We're going to be doing some testing with Bureau of Reclamation to try to, again, look at repeatability amongst all the different field sampling protocols. 2020 goals for this next year, that webinar that looks at the state of the science, again, that white paper that we hope to receive comments back on, get those SOPs out for comment, and then I think the next big step here is to come up with a template for a communication plan. So those are our big goals for the next year. And I thank everyone here for assisting with that, and we look forward to a good discussion here shortly.